wanna sleep in, cause I got something to prove. I gotta take what I hate and finally make a move. I think of you and
Atom, they are going for holiday. Good morning and Assalamualaikum. I hope you are fine and happy always. Do you know synchronous counter? Today, our team will show you how to design synchronous counter using D flip-flop. They are slightly different between a synchronous counter and synchronous counter. You can design synchronous counter like this. Just follow 5 steps to design synchronous counter. So, what are you waiting for? Let's check it out!
when you should be getting after it. I got facts over tracks, this and that, spitting slow, spitting fast. I could roast, I could gas, think I'm okay at last, but I don't know if that can erase all the past and the pettiness, a reflection of the empty.
The easy way to design synchronous counter with one condition. Just follow 5-step design. Let's say I give one example.
Design a synchronous counter to count number 4, 7, 3, 0 and 2 respectively using D flip-flop with positive edge trigger.
So, for the step 1, we must determine the number of bit or number of flip-flop used. So, this is the formula. The power of n equal to capitalized N. From the formula, capitalized N is a mode must be maximum number plus 1. As we know from the question, the maximum number is 7. So, capitalized N equal 7 plus 1, we get 8. It is equal mode 8. From the formula, the power of n is equal to 8. Then, we use log 8 divided by log 2. Then we get 3. So, the answer is 3 bit equivalent to 3 flip-flop. Now, we go for the second step. Draw the state diagram. First, we know 5 sequence number start with number 4, number 7, number 3, number 0 and number 2. Draw a 5 circle and write this number in binary form with 3 bit as finding in step 1. Next, create an arrow with starting from number 4 until all the circle connected. For example, number 4 is 100 in binary number. Next, for 7 is 111. Then 3 is 011. 0 is 000. And the last one is 2 is 010 in binary. Now, we go for the third step. This is the most important step to differentiate among types of flip-flop use. Please give more attention. Build the excitation table from the transition table. In this case, we use the flip-flop transition table. For the present state, we follow the sequence number from state diagram starting number 4, 7, 3, 0 and 2 in binary number. For the column next state, just skip one sequence number from present state, which means starting with number 7, 3, 0, 2 and the last number is 4. For present input, we focus on first column, QC present state and next state. To write the present state and next state, you must refer to the transition table. Bit 1 change to 1 represent input 1 for input DC. Bit 1 change to 0 represent input 0 for input DC. Bit 0 change to 0 represent input 0 for input DC. Bit 0 change to 1 represent input 1 for input DC. For the second column, the same method will be implemented. Bit 0 change to 1 represent input 1 for input DB. Bit 1 change to 1 represent input 1 for input DB. Bit 1 change to 0 represent input 0 for input DB. And the last bit 1 change to 0 represent input 0 for input DB. So, for the third column, you just follow the same method as I explained before.
So, this is the fourth step to design synchronous counter. In this step, we need to build kind-of map from the excitation table. We use present state output for mapping the input D in this K-map. Any empty cell will be put the symbol X to represent don't care input. Don't care means it will be logic 1 if necessary to make sure the larger number 1 grouped in looping process. If not, don't care condition will be ignored as logic 0. After kind-of map complete, the simplification expression will be created from looping. Remember, if a wrong mapping and make a mistake in looping, that can change the final result. Knowledge to use K-map is very important in this step. Now, we go for the last step, perform synchronous counter circuit. We know the number of D flip-flop used in this designation is 3 bits or 3 flip-flop as stated in step 1. So, we actually can draw the basic process in this designation with 3D flip-flop with positive edge trigger. For each input D such as DA, DB and DC, we can draw and make connection according to simplified expression in step 4. Please take note, the term of A, B and C in this explanation represent output QA, QB and QC. And last, make a connection for each input needed.
How about it? It's quite easy, right? So, if we do a lot of practice and follow these 5 steps, we can do for various synchronous counter. That's all from our team. Make it easy and don't take it easy. See you soon. Bye-bye.